recording. Love it. Right, D. So on whatever day it was, Thursday, I gave you guys techniques for looking at things like this. Division with decimals without using a calculator. Does anyone remember the technique? Yeah, Carolyn. Yeah, how did we get it to that point? Okay, so because I've got two decimal places here and I've got two decimal places here, I can move them both to the right the same amount. The mathematical reason for being able to do that is multiplying both of those numbers by what? By 100. So multiplying this by 100 and this by 100. Does anyone, you guys remember why we can do that? Like why that's okay? Does anyone need me to re-explain why we're allowed to do that? Yes? Okay. Because division is the same as what other mathematical structure? A fraction. So this guy right here is basically just this fraction, negative 0.55 over 0.11. And if I have a fraction, I can rewrite that fraction as another, no, don't want to do that. I'm going to rewrite that as another similar fraction. To make a fraction similar to another fraction, I'm going to multiply the top and bottom of this thing by the same value. Because multiplying the top and the bottom of something is just like multiplying it by 1. So I'm going to multiply the top and the bottom here by 100, and that's going to give me negative 55 over 11. Well, that's the same thing as what I've done here. I just haven't written it as a fraction. I've written it like a division statement, but these two things mean the same thing. That's why I'm allowed to move that decimal around like this. As long as I do it to both, the question doesn't actually change. So it's going to go 2 to the right. It's going to go 2 to the right. So this becomes negative 55 divided by 11, and that is a number you should know. That is negative 5. Because your multiplication tables should be strong. No, it's done. Like, think back, like look at it as a fraction. I multiplied the top and bottom by 100, so that's like multiplying by 1, doesn't change anything. This fraction and this fraction are exactly the same, and this fraction here reduces to, I can divide top and bottom by 11. That's going to become negative 5 over 1. Well, negative 5 over 1 is just negative 5. Nowhere here did I undo what I had done here, because all I'd done was multiply by 1. So because this whole chain is fine, this is fine, and I don't do anything to my final answer.
So does that work all the
Yeah.
time?
Yeah. Because, well, when I'm dividing, because all I've done here is multiply the top and the bottom, the numerator and the denominator, by the same value. It doesn't actually change anything. Because what I've done is I've multiplied it by 100 over 100, and 100 over 100 is, so 1, a whole. And does multiplying by 1 change anything? No. And so this technique here, and you've seen it before, and whether your teacher pointed it out to you or not, what you've done here is you've multiplied it by 1. It's just not always going to be the same 1 that we multiply by. Sometimes we multiply by 100 over 100. Sometimes you might multiply by 3 over 3 or 4 over 4, depending on what the common denominator I want. We're always going to multiply by a different 1, but multiplying by 1, whatever that 1 is, doesn't change the question. That's why we're allowed to do what we just did. Does that help? Okay. So then G, we want to go back. Carmen, you wanted G, yeah? I've got negative 1.1 and in brackets 2.3 minus negative 0.5. So what's the first thing I'm going to do here? Bedmath says I do what? Brackets. And so I've got 2.3 minus negative 0.5. Subtracting a negative is the same thing as adding a positive. So I'm just going to extend that line and turn that into that, just for my own note's sake. So I got 2.3 plus 0.5 So it's going to become negative 1.1, and then in brackets, 2.3 plus 0.5 is 2.8. And I can multiply that guy together longhand. 1.1 times 2.8, that's just going to be 2.8 times 1.1. 1 times 8 is 8, 1 times 2 is 2, add a 0, 1 times 8 is 8, 1 times 2 is 2. Add those things together, and I'm going to get 8013. So I'm going to get that this thing is actually going to be 308, except it's not 308. What do I do with the decimals when I'm multiplying, Harwin? Yeah, no, you're right. Yeah, so I have two decimal places here. I got one here and I got one here. So my final answer needs to have two decimal places, the same number as the total of all the numbers I multiplied. So my final answer is going to be 3.08. And it's just going to get there. Yes, absolutely. And it's going to be negative because the 1.1 was negative. So because I have one of these values was negative, that makes my final answer negative, and there we are. Carmen, does that make sense? Okay. Do you still want me to do I? Let's do I. Regardless of whether or not you want it, we're doing I. What's the first thing I need to do here with I? Why? Because you read it left to right. Good. So I got the 1.8 times the 5.7, and multiplication and division can be done in either order. So we're going to go left to right. 1.8 times 5.7. We're going to do that longhand. 1.8 times, that's 5.7. Come on, Dweedoff, get it right. 8 times 7. I'm pretty sure I hate that one. That's 56, right? 8 times 5 is 40, plus 5 is 45. Add the 0. 1 times 7 is 7. 1 times 5 is 5. Add those things together. It's going to be 6, 2, 1, 10. So 1026, and I need two decimal places because I had two decimal places there. So I'm going to have 2.4 plus 10.26 divided by negative 2. Yes? We're checking my work and I'm doing okay? Because it's Tuesday morning after a long weekend. I can make mistakes too. So then my next step is to divide 10.26 by 2. I could do this using long division, or if your mental math game is a little bit strong, you're going to get what Harwin just said. Both of these divide nicely by 2. There's nothing weird going on. 10 divided by 2 is? 26 divided by 2 is? So this is just going to give me 5.13, and it's going to be? Someone said it louder. Thank you. Because that 2 is negative and that's positive, so a positive divided by negative is going to be negative. So I'm going to get 2.4 minus 5.13. And then we had a technique for this. It's close. The technique we had for this is if I'm subtracting by a larger value, what I'm going to do is I'm going to do the bigger minus the smaller, and then my final answer is going to be negative. So it's going to be 5.13 minus 2.4. When I'm adding or subtracting, I line up my decimal places here. 3 minus nothing is 3. 1 minus 4 I can't do, so I borrow from the 5, it becomes 11. 11 minus 4 is 7. 4 minus 2 is 2, so it's going to be 2.73, and it's going to be negative. So I was wrong. It wasn't even close to 3.9. Negative 2.73 should be your answer for I. Comments, questions, concerns? And J happens basically the same way. What do I do first in J? Yeah, the addition inside the brackets. So we're going to add those together. It's going to give me something. Is that negative 1.7? I think. And then I'm going to multiply by 1.2. Is this number right? Yep. Thank you. That makes more sense. 1.7 wasn't looking right. Negative 0.7 makes more sense. Right, yeah, because that, yeah, no, thank you. So then I've got 1.2 times 0.7. That's very similar to 12 times 7. 12 times 7 is 84. Thank you. Is that Ty or is it someone behind Ty? It's Gavin. Thank you, Gavin. 12 times 7 is 84. So 1.2 times 0.7 is going to have 2 decimal places. So it's going to be 0.84. And it's going to be negative. So I got negative 4.36 minus 0.84. When I have a negative subtracting something else, I can just add these two together, and then my final answer is going to be negative. So it should be 5. Yeah. Negative 5.2. Is that right? Yeah, because that 4 is going to make that 6 is 0, and I carry the 1, so it's going to be 1, 2, 3, 4, and 8 is 12, so 2, carry the 1 is, yeah, there it is, negative 5.2. Was there any other question? Oh, and then we're cool with number 3, the word problem here at the bottom? We understand what's being asked of us down there? Sorry? Yeah, it was on the page. Sure, let's talk about it. One January day in Penticton. This is actually great because it's going to lead. Actually, no. I'm not going to talk about it. First, before I do that, I'm going to go back now that I've taken up those questions, and I want to give you the answers to the homework I assigned. So these are the answers to the first 10 questions are right here. I'll make sure I box it. So I have 1/2. There's 12 over 7, 8 and a 6th, 12 and a 5th. Negative 2/3, that's 37 over 14, 23 over 12, negative 1/2, 16, and 6 over 11. So those are my answers. Oops, sorry, bottom one. Yeah, you can leave things improper. Mixed? You want them mixed? You want me to put them into mixed? You're good? Okay. Questions about any of this? Remember the technique here with the number 6. If you can cross simplify, to cross simplify when you're multiplying fractions together, you want to make sure you do that. Don't forget, it's a technique you want to hang on to. Any other questions? Any questions on this page? Are we good? We done looking? Going once. Yeah. Jay? Number 9? Sure, let's do number 9. So with number 9, what I did, here, I'll just actually show you number 9 start to finish. So number 9, first thing I did was when you've got mixed numbers multiplied together, what I saw some of you do on that quiz that I gave you last week is you multiplied the numbers out front and then you multiplied the fractions together. Yeah, I can do that. You can do that with addition because what this mixed number means, this is 3 plus 1/3 is how you read that. Or 3 1/3, same thing. It's not 3 times 1/3. So you can't rejig all of the multiplication by multiplying the whole numbers and then multiplying the fractions. That's one thing. One mistake I saw in the quiz that I gave you that I wanted to make sure I addressed and totally forgot back then, but I'm addressing it now. To multiply fractions, or multiply mixed numbers, you have to make them improper, and then you have to multiply those improper fractions together. So to make this thing improper, I take the denominator, I multiply it by the mixed number. So 3 times 3 is, plus 1 is. So this is going to give me 10 over 3. Are we cool with why that works, or do we need an explanation as to why that's a thing? Carolyn, are you doing okay? Okay. So we got 3 1/3. And I'm going to multiply 5 times 4 is, plus 4 is 24. So now I'm going to multiply across the top. 10 times 24 is 240. Oh, hold on. I could do 240 over 15. I could do that. The other option is to do what? I can do some cross simplifying here. Because 24 and 3 are both divisible by 3. I can divide by 3, I can divide by 3. And what other cross simplification could I make? Sorry, I'm dividing. 10 and 5 can both be divided by. So this could change the question. Instead of having 10 over 3, 10 divided by 5 is? 3 divided by 3 is? 24 divided by 3 is? 5 divided by 5 is? So this becomes 2 over 1 times 8 over 1, which is 16 over 1, because I multiply the numerators and the denominators. 16 over 1 is just 16. If I multiply across the top and the bottom, I get 240 over 15, and then you can see this thing can be reduced because both of these numbers are divisible by? They're divisible by 5. But then we have to go 240 divisible by 5. I don't know what that is. We could do it, but by cross simplifying, we're able to reduce our workload later on. Cool? Comments, questions, concerns? Yeah? You may. So that was the first piece of homework I got you to do. The second piece I wanted you to do was this chunk here. I'll zoom this out a little bit while you're checking on that. Take a look at what you got. If there's any questions, let me know. Okay, questions, comments, concerns, A through K. We're good? Anyone want to see any of these? Yes, you will. I'm getting there. That's why I said A to K, because you haven't even seen E, L, F, M, G, and N. Sorry. Come on. Okay, there you go. There's that. Come on. There we go. Yeah. For G. Yes, but conventionally, it's always the top. What if you put the negative on the bottom? I won't do anything with that. You just never see that. It means the same thing. I would mark, okay, so guys, there's a couple questions here that I want to make sure you all hear. So first, Kyla said, well, what if I multiply the negative 2 and the negative 5, so shouldn't that be positive 10, and then it's the 3 times the negative 6, that's negative 18. So you want me to write it like this, 10 over negative 18. If you did that, yeah, absolutely, that's correct. But the other piece to that is, it's not convention. You never see it written. You will never see it written like that when things are written down as a fraction. What you'll see is either this negative goes in line with this line here, or it gets absorbed into the numerator, which is what I've done. These are exactly the same expression. I would not mark this one wrong. I would just let you know that for the sake of things, for the sake of what you're going to do later, this is not the way that you want to typically write these things down. You want to go this route here.
So you can like toss either side of the fraction all over the place, and it doesn't matter. Or did I not write that?
I don't like how casually you said that, but effectively yes. What you need to recognize, we're not tossing them anywhere. They're equivalent representations, and some equivalent representations means they're all equal, but some are better than others. Just like an animal farm, yes. All the animals are equal, but some are better than others. Yes, just like Animal Farm. Some are more equal. Is that how they say it? Yeah. This is just like that. They're all equal, but some are more equal. Okay? Are there any other questions with this page? Okay, then flipping the page, here we go. Here is the top. Yeah, Carmen? This one? 56 over 405. 56 is divisible by 2 and 28. It's divisible by 4 and 14. Oh, you got 450. Yeah, you gotta be careful with that. 56 is what? 4 and 14, 7 and 8. And I don't think 405 is divisible by any of those things. 405 is divisible by 50, no. 81 and 5, which makes it divisible by 9 and 45, and that's it. No, P is not reducible. So then sliding this up, we've got D, I, E, J, and I won't show you number 3 because we'll talk about 3 here in a sec. There's the bottom. What time does this class actually end? It's a double block, right? The double block ends at 11:25. Okay, so, we cool? Anything, any grief? Hearing nothing? Sorry, does anyone want me to do anything here? I'm hearing things. Yes. Eminent. R. Okay, let's do R. This guy here? Okay, so First thing we're gonna do. So I'm gonna do this thing in chunks. First thing I'm gonna do. Or I mean, if Angel wants to do it, Angel, you want to do it?
No.
Were you explaining it to her?
No, I got it on too.
Oh, okay. So
Yeah.
this is this page here. It's before the calculate, no calculate. The ones you guys asked about, G8, that was this chunk. They want to see R. Okay, so the first thing I'm going to do is to make our life a little bit easier. I'm going to do some cross simplifying. Oh, I mean, actually, we don't even really need to do some cross simplifying. We could. Let's do some cross simplifying. The 2 and the 6 can be reduced here. Excuse me. The 2 and the 6 can be reduced. Both those divisible by 2. So this can become 1/3 times 1/4. A third times a fourth is 1/12. Okay, cool. Minus. Now, the way I'm going to write this is I'm going to chunk it down piece by because it's so nicely broken up. That's my first set of brackets multiplied. I'm done that. Now I'm going to move over and do this chunk of brackets right here. 5/2 divided by 4/10. When I divide a fraction by a fraction, what do I do? Multiply by the reciprocal. So I saw some of you doing this. Yes, this is what I want to do. I have 5/2. I change the division to multiplication, and 4/10 becomes 10/4. Now, at this point, you can cross simplify. Before we couldn't. You have to wait until you've got multiplication until you cross anything. So now I've got 5/2 times 10/4. Is that cross simplifiable, or should I just go for it? Cross simplify. So if I'm going to cross simplify, what am I going to do? 2 and 10 are both divisible by? Okay, so that's going to be divided by 2, divided by 2. So that's going to become a 2. That's going to become a 5. And now I'm just going to go for it. 5 times 5 is? That's 1. Thank you. 5 times 5 is? 1 times 4 is? Cool. And I'm going to add to that 3 times 5/6. 3 times 5/6 is what? 15/6. Because that's just 3/1. So then I multiply 3 times 5, which is 15, and 1 times 6, which is 6. This is different than 3 and 5/6. Not the same thing. This is 3 times 5/6. So it's going to be 15/6. So now I need a common denominator of 12, 4, and 6. The smallest number that those three go into is 12. So that stays 12. This 4 is going to become a 12 by multiplying it by. And whatever I do to the bottom, I have to do to the. So times by 3, times by 3. And then the 6 and the 15 are both going to be multiplied by. Times by 2, times by 2. So this is going to become 1/12 minus 75/12 plus 30/12. I can't see. That's from something. What's that from? Oh, it's a movie. Anyway. 1 minus 75 is negative 74 plus 30 is negative 44. Did I do that right? And then the denominator just stays 12. We good? I've been hearing dissension. We're cool with that? Yes, sir, Jay? Yes. That is Jay. Oh, it's Gavin, sorry. When you add or subtracting fractions, the denominators don't change. Only when you multiply or divide. Because you have a 12th minus a 7 minus a fraction over 12 minus a fraction over 12 plus a fraction over 12 is going to give me a number of 12ths. Bottom doesn't change. Sorry, Gavin. So I've got negative 44/12. Is that reducible? You bet it is. 44 and 12 are both divisible by, giving me negative 11/3. which you could then write as -2 and 2 over 3, yes. Because, sorry? No, it'd be 3 and 2 over 3. It'd be 3 and 2 over 3. It'd be -3 and 2 over 3. It always goes out as far forward as you can put it. Okay. The last thing I did want you guys to actually do was this question down here. And in the past, this is the first year that I've really started to, sorry, this question was always there. It was a kind of a one question at the end. And then on your chapter test, I throw a couple more word problems at you there. And those ones, for whatever reason, they're the great executioner. That's where the emotions go to die on that test. Because students are flipping, they're like, yeah, I can multiply fractions, I can do this. And they're like, what the frick just happened? And then everything just falls apart there. So I have provided, you can see the next page is a ton of word problems. And so I don't know how much pages. Yes, there should be like 4 of them. Because I don't know how much word problem experience you guys get in middle school. I know there are teachers in this building who do nothing with word problems in grade 9 because their Math 9 students are just so bad at them. They're like, I'm not even going to try. So I don't know where you're at. I know some of you are going to be really good. Some of you are going to struggle. And it's really not that hard. And I just want to expose you to how to think through them properly because we're going to do some real gross word problems after spring break. And the math is going to be harder with the ideas in the questions being fairly difficult too. So I want to make sure that we're cool right now with some of these simpler ones. So I gave you this question for homework. It says one January day in Penticton, the temperature read -6.3 degrees Celsius at 10 a.m. and 1.4 degrees Celsius at 3 p.m. What was the change in temperature? Jay, is that your hand? Do you have a hand you want to throw up here? Or are you stretching? So, okay. So someone tell me what's happening. Explain. Danny. As the day goes on, the temperature gets higher. As the day goes on, the temperature is getting warmer. So when you're dealing with, if this was just a standard subtraction question, the temptation for this question, you know what, no, forget I said it. I won't do that. Okay. I'll just go back to what Danny said. Danny, as the day is going on, the temperature is getting warmer. So if as the day is going on, the temperature is getting warmer, how do I figure out what the change in temperature is? Yes, Harwin. What am I subtracting? In what order? Because the order matters. Why? So, okay, so we were at -1.63, negative 6.3 at 10 a.m. And then later in the day, here we are at 1.4 degrees Celsius at 3 p.m. So if the temperature changed, no. The temperature changed. That was not supposed to be a question. That was supposed to be a statement. The temperature changed. How did it change? Danny said it got warmer, which means the temperature went up. Okay? If I do negative 6.3 minus 1.4, my value is going to be, it's going to be lower. Because I'm at a negative value, taking away something positive. It's going to be more negative. Does that make sense? If it's getting warmer, can my change in temperature be negative? No. It shouldn't be, no. Because a negative in that case, if my change in temperature is negative, that means my temperature did what? Went down. This is where that negative, remember we did absolute value, the negative signified a direction. That becomes really important when we're talking about a change in things, because you can change up or you can change down, and that negative will tell you which way to go. If the day is getting warmer, which if you think about it makes sense, my final answer should be positive, and the only way I'm going to get a positive value here is if I take my later time and I subtract my earlier time. Carolyn, is that what you're going to say? Danny, is that what you were going to say? Okay. Here is a general rule that I'm going to present to you. Change in, I want you to put a box around change in. Change in is something that you're going to see time and time again. It's going to show up in science class. It'll show up in primarily chemistry and physics. And what a change in means, a change in is always understood to be a final value minus your initial value. And so in our question, the final value is the 3 p.m. value because it's later in the day. Time goes forward, not backwards. Unless you're into quantum chromodynamics, and then I'm supposed to tell you that time travel is possible, but I'm not supposed to tell you how. So forget that I said that. Don't worry about it. We'll do it later. Don't worry about it. Maybe you'll see it later. It's true, but yeah, it'll just make it worse. Time travel is possible. I had a professor in university who was one of my physics courses, my 4th year physics course. He said right at the end of class, he's like, and as we've shown, time travel is possible. Have a good day. I'll see you later. And he walked out. And we're like, wait, what? What? And he was gone. We're like, what do you mean time travel? And that was Friday afternoon. So he walks in. We come back Monday morning. I'm like, you had a bold statement in class on Friday. He's like, I know I did. But none of you actually have the education he told us this in 4th year. He's like, you guys haven't been taught the material that I need to be able to teach you to show you that the statement I said was true, but it follows from what we did in class on Friday, and you'll have to do a master's in physics to understand why that's true. And so that was it. I did my master's in math. My master's was in math. I have seen the concepts that suggest why time travel is possible, but I don't understand it enough to be able to teach it to you. It's wild. Danny. Yeah. 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 It's yeah.
If you get smaller than
yeah. It's a thing. It's complicated, and we don't really know what goes on down there, but it's legit.
That's an actual thing.
Kind of. Not exactly as they depicted it, but the ideas are there. Nika. Because, well, you going back becomes your future, and so things get complicated. So you're not actually changing anything, because it's... No. Anyway, so change in, ladies and gentlemen, means a final value minus an initial value. So in this case, my question is going to become 1.4 degrees minus negative 6.3 degrees. 1.4 minus negative 6.3. If I am subtracting a negative, that's the same thing as adding a positive. So that's going to be 1.4 plus 6.3, so that's 7.7 degrees Celsius. And if the question is posed to you in a sentence, your answer must always then be posed as a sentence as well. So what is my final answer to this question? Sure, we could say from 10 a.m. to 3 p.m. We could add that. I don't have a lot of space, so I'm not gonna. But the change in temp was 7.7 degrees Celsius. Period. Yes? Is it about this or about the stuff from before? No, hold on to it. We'll come back to it later. I'll give you some time later to ask about it. Okay, so how, yes, to me? It would still be final minus initial. So it would be negative 1.4 minus negative 6.3. You'd still get a positive value because it would be then it would become negative 1.4 plus 6.3, which would become 3.9. 4.9? 4.9, and it would still be positive. So even though the final temperature is still negative, the temperature did go up. And so the change in has to be positive. Does that make sense? Okay. Okay, so what I want to do with you guys today is we're gonna split the class into 2 blocks of time. The first chunk of time, I'm going to give you time to play with these word problems. I'm not going to give you a lot of instruction on how to talk these things through. I just want you to want you to start working on them. I'm going to float around. I'll clear up things as they need clearing up. Do I put the answers with these? I don't know if I did. Oh, I totally didn't. Whoops. I'm not going to give them to you yet. I will give them to you later. What I want you to do is I want you to, with the people working with you, because almost all of you are working partnered with someone, I want you to talk your way through these things. The one thing I want to avoid, and I don't know why this is, but it's always the guys. Guys, don't do what I'm about to say. For whatever reason, I don't know why, whatever it is. I don't know why it is, but the goal always seems to be to write down as little as humanly possible. Generally, it seems to be the guys. Maybe ladies, that's you too. That will not be acceptable in this section. I want you guys to show all work when given word problems. Okay? I want you to show all your work. And I want you to do the evens. You've done them already? Danny? Okay, so Danny's got a question. So we're going to do with Kaylee. So number 1, when I say show all your work, I mean I actually want you to write out the equation. So Danny, keep going. With Kaylee being
Kaylee is 30 years old because.
No, I want to see the math. How you got that? How do you get that she's 30?
Or 30 plus 13 is 43.
So you did it this way. You said okay.
Or 43 minus something is 43 minus 13 is.
So if she's 43 years old in 13 years, you take how old she will be minus the time between then and now. That's going to give you 30 years. And then you were going to write me a say, like, that's not overly difficult. That's fairly straightforward. It's just getting, and again, these questions aren't supposed to be hard. But what I want you to do, what I'm going to force you to do here is, even with this simple math, like you could look at the answer, oh yeah, obviously it's going to be 30. Why? Mathematically, give me valid reasons why that's true. With this one, I'm going to throw you a little bit of a curveball here, because I want to see all your work, but I'm going to allow you to use a calculator. Okay? So what that means is, so for a question like number 4 there, Deshaun spent $33.60 on batteries if they cost $4.20 a pack. How many packs did he buy? How would you go about finding the value for one of those packs, Kyla? Number 4. Okay, ladies on the side here, and gentlemen in the back, stop talking. You just guess 8 as a result. Okay, so but if I... Yes, but what do you do with it? Like, how do you... What's the mathematical procedure for figuring out how many packs there were. Yeah, Danny.
You just have to figure out how many times $4.20 goes into $33.60.
Yeah, so
And you can even divide it. Yeah, because you know that 20 goes into 60 3 times, but that doesn't really matter, because that's not going to matter if you
okay, so the part that I want to, you're right, Danny, but the part that I want to dig in on is the first thing you said. When we've got a question like this, and this is where I see the struggles show up, and I don't necessarily know why that is. The thing that Danny said is what I like to hear. To figure out how many battery packs there are, what you want to do is you want to find out how many times $4.20 goes into $33.60. We have a mathematical operator that does this. What is the mathematical operator that figures out how many times this number goes into that number? It's division. So I'm going to take 3360 and I'm going to divide that by 420. Those of you, the enterprising ones among, I like to write it as a fraction. It makes it nice and easy. This is, some of you said it already. You only move the decimal place once, I think Angel said. This is the same thing as 336 over 42. Why did you only move the decimal place once? Because it's a 0 on the back end, so we can ignore it. Cool, love it. So we move it, just multiply by 10, so this is going to give me 336 over 420. And you can reduce that fraction a bunch of times if you want, or you could long divide that thing, or you could recognize that 8 times 40 is 320, and then that gives me another 16 left over. So then there's the 2 there, and 2 times 8 is 16. You could do it that way too. But what I want you, regardless of how you reason it through, I want you to show me mathematically why that works. And so in this case, this is how you'd show it. And what am I doing here? Let's say, I don't know, let's say divide both of these by 2. So 336 divided by 2, I mean, if that's how you want to do it, I don't know. That's a gross number to do, though. Let's divide it by both by 6. 6 goes into 300 50 times, and 6 goes into 36 6 times, so that's going to be 56. And that's a 7. But then 56 divided by 7, oh, that's one of the multiplication table ones that I hate, but we know is it's 8. And so I have shown you with sound mathematical reasoning why it's 8 packs. Yes, Danny?
I just skip counted before. But that's because that would take way longer than, or way less time than doing all that fraction division.
Perhaps.
Yeah.
But all I have to do, so Danny, you said, and here's the danger, I'm seeing this in my Physics 11 class, which is why I'm glad, Danny, you said you'd skip count. So 420, 420, 420 is 840.
Or just 4 times.
Yeah, you just go up like that. All I have to do to make that impossible for you to do is what? To skip counting to be faster than this. All I have to do is crank up the values of my numbers. This procedure, the reason division exists, and I'm allowing you to use a calculator, is because there's a reliable technique that will work 100% of the time. Division. It's division's job to tell you how many times this number goes into this number. And that's what I want you to recognize from a question like this. Some of you say, oh yeah, I'm just going to skip count. Okay, cool. Fine. Then I'm going to make this number monstrous. What if I told you that he spent $5,187 on batteries at $4.20 a pack? Skip count. Go. Or you'd be here forever. Or how do you figure out how many dollars how many battery packs 5,187 will buy you? The technique for that is, and again, it goes back to what Danny said at the beginning. You want to know how many times this value goes into this value. So to figure it out, Danny said it before, divide. And I'm allowing you to use the calculator. So what's 5,187 divided by 4.2? I will answer that question in a sec, Carmen. How many packs of batteries did he buy? You betcha. And you could skip count your way there. Or, but this also represents the number of times you're skip counting. You're skip counting 1,000 times. Over 1,000 times. It can take you forever. So again, just because you've got a simple technique that works, all I gotta do to make your life miserable is to crank up that value. Okay, before I release you, Carmen. Yes. I want you to attempt the evens, and okay guys, if you've already done all of these, because you looked ahead and you're like, oh, these are easy. If you used techniques like skip counting, if you use techniques like, or if all you do is write me down an answer, I want you to go back, I want you to do them again, and I want you to give me valid mathematical reasoning for why it is the way it is. If you show me something like skip counting, I also want to see you use one of our fundamental operators, addition, subtraction, multiplication, and division. I want to see that you understand how to apply those things in these kinds of cases. Do not skip count your way to a final answer. Because all I have to do to make that not a valid way to do it is by just making these values bigger. Cool? Go. And I will come around and deal with you all individually. You're allowed to do that. So I got A and N. Yes. Correct. Copy negative. And does that, now think about that answer, does that make sense? If he ran 26 kilometers and he ran 14 less, there's 14 less than 26. So then what you've done here is correct. Because you took your answer and then you just applied it to the question that was given to you. So, and this is exactly how I would set this up. That's good. And the purpose behind the word problem is just so that I can see that you guys can decipher from the language the ideas that you're trying to. That's it. You just can't do the same thing. Yeah, you're good. Use the new variables, and I'm not going to do that because that'll freak out some of your classmates. But that's fine. A plot is a chunk of land. Oh, that's another thing. Okay, so, ladies and gentlemen, I do want to address one more thing. If there are words, concepts given to you in a question that you don't understand, please ask. I don't care if it's a test or quiz or a piece of homework. If you don't understand, like, so this was question number, what number was that? 8. Question number 8. So question number 8 talked about 8 workers are hired to harvest potatoes from the field. Each is given a plot. A plot is just a section of land. I got a real big field, and I don't want all of you to work the entire field. I want you to work this piece, and I want you to work this piece, and I want you to work this piece. Those individual pieces of a field that you're going to work, we call it a plot. It's not like what happens in the story. It's a section of it. It's a section of land. So there's a few things that you guys are going to, that'll come up a few times. If not here, it may or may not show up later. Wink, wink. And it will be a plot, it will be a different construct that you may or may not understand. What do you call the area zone? Oh no, we call the area for 1. It's 35. And we made them. Yeah, that's right. All it is area of 1 times number of no, sorry, one, sorry, I can hit. The rest of the countries are cups of sugar. Subtract it. 3 and 4 minus 3 and 6. That's it. I don't know if your final answer is right, but that first this is what you wanted. Then you took this and you turned it into a plus. So then 9 times 3 is 27 plus 4 is 31. 6 times 3 is 18 plus 1 is 96. 31 minus 96. Very clear. So then you common denominator, so not by top line to it. Top line to it. 5 18. No. Time travel has nothing with wormholes. And as it stands right now, time travel is only possible on the single particle level. So Danny was asking about like the quantum realm and Ant-Man and that kind of stuff. Yeah, on that level, time travel is possible. We haven't been able to attend it. Time travel is theoretically possible at that level. Give me more. Do not just give me answers. Give me reasons for your answers. Valid mathematical reasons. And I'm going to find the answer key to this stuff. Okay. Get bigger. Let's come over here. We'll put it there. Hello.
So is this
So yeah, you took the value, you added the area for 1, and then you multiplied by 8 of them. Yeah.
So that's a reason?
Oh, the mathematical reason.
Yeah.
This is the mathematical reason.
Okay. Okay. So you don't have to like put in word form and explain the answer.
I want mathematical reason. I don't need a paragraph that tells me how you solved it. That will come later. I'll give you other stuff I want to ask. Doesn't matter. It's gonna happen. So whatever. What did he do? He gave you like these problems to solve? Like that number not solved? If you haven't noticed, the answers are now on the screen. Nice. So if you're done, check your work. The answers are on the screen. If you finish them, that's cool. As you can see, the answers are still on the screen in front of you. Make sure that you're happy with those things. I'm not going to spend a lot of time looking at exactly what you've done. If you've got questions you want me to address them, I'm happy to do that. The last piece, though, to this document is this review. And it says here, number systems unit review, and then there's a name and a, oops, sorry, I should do this. This is where you're going to lose the answers. If you want the answers, take a picture of them. If you want these answers, still take a picture of the screen right now. 5. That is the answers for the word problems. 4. Sorry? No. 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 3, 2, 1. Bam. Bam. Okay. So, no, you don't get the answers to the review. No, you don't get the answers to the review because I use the review as a form of assessment. So, guys, ladies and gentlemen, Olivia and crew at the back, and gentlemen back there who aren't looking, and Rebecca, once your face. Starting at this page, all the way to the back, I am going to be taking this in. I'm going to be assessing you on it, I'm going to give you feedback for it. Okay, so this is another way. So it's going to form part of your final grade because I don't want everything just to be sitting on this high pressure, hyper concentrated test scenario. You'll have time to work on this. You can consult with other people, but I'm not going to give you the answers to this thing. I'm going to assess it myself afterwards, give you some feedback on it. So it's just another kind of a lower stress way of seeing what you're able to do in a slightly different environment. So again, no calculator on this first chunk. Please circle your final answers for questions for more than one step. We're going to go through it right now. So I have this thing in front of you, and I'm going to show. I'm going to reduce the size of some of these sections just to make your life a little bit easier, I think. Where do I want to do that? Okay, so flip forward till you see the roots review. Up to roots review, I want you to do all of it. When you hit roots review, okay, ladies on the side, stop talking, please. When you hit the roots review, I want you to do the evens. Flip the page. It'll say simplify the exact value here. Here I want you to do 10, 12, 13, 14, and 16. Yeah. I'm shrinking it slightly. Okay. The absolute value review, there's not a lot there, so I want you to play with all of those. And then there's a whole section on word problems. For the section on word problems, I want you to do odds. Here, where you get to this last page, I want you to do odds on those ones. There are, sorry? Odds on the word problems. If you do more than I ask for, sure. Just don't do less than I ask for. Okay, so that's it. You can spend, I'm going to give you some class time to work on this. You will have the rest of the class today for sure. I will likely give you some time tomorrow. Thursday, we're going to start the next unit, and your test is still Friday morning. Nika. Yeah. Things don't change until you hit the roots review. Roots review evens. You're going to flip the page where it says exact value. I took off 3 questions there. Absolute value you're doing all of, and then the word problems you're going back to doing odds. So I'm making some of it a little bit smaller, but not all of it. And this thing you are going to do, and then you're going to pull it off the back of your package. You're going to staple together. You're going to hand it in, and I'm going to take a look at it. Okay? So that's that. Rest of this class, you can work on any piece of that. I can help you. You can work with people sitting around you. The review is designed to help you go through the things that I will ultimately be assessing you on Friday. Yes?
So every single thing in this thing is what we're being tested on.
It's going to show up on Friday, yes.
Okay, but I thought Friday was a staff learning opportunity.
Yeah, doesn't matter. No. Some of you may have been told it's not a tutorial, it's actually an SLO. I can't give you this test on Thursday because it's a short block to do it, and I don't want to give it to you tomorrow, and I'm not going to move it to next week. So I still want you here, even if it says SLO, I want you here Friday morning, 8:10. We'll do it Friday morning. Okay.